me, 4 over 9 minus 1 over 5. 4 over 9 minus 1 over 5. So we're going to start with very basic here. And last week we talked about doing what's called a butterfly method. There's more than one way for us to simplify this and not using a calculator. So no calculators are allowed during this point. We're going to go 4 times 5 in just a second. I'm going to put that value here. I'm going to take the symbol. In this case, it's subtraction. Now in the second parenthesis, I'm going to take 1 times 9. This symbol is only used in the middle. It's not used when I'm multiplying. On the bottom, I'm going to take the product of the denominator. So here we go. 4 times 5 is 20. 1 times 9 is 9. And 9 times 5 is 45. I'm going to take 9 away from 20 to get 11 over 45. Simply taking a calculator and going, okay, 4 divided by 9, subtract 1, subtract 1 divided by 5, turning it back into a fraction. That doesn't tell me you understand math. That tells me you can plug something into a calculator. Let's try the next one. If you've just come into class or you're watching this video, there will not be calculators allowed for this. So you need to know how to do it without the use of a calculator. 3 times 5 is 15. We always do this diagonal first. I take the symbol in between, whether it's adding or subtracting. It goes in between these two values. 1 times 7 is 7. Again, I do not use the symbol when I'm multiplying. It simply is used to go in between these two values. In the denominator, we're going to take the product of the bottom. So 7 times 5 is 35. If I take 7 away from 15, I end up with 8 over 35. And this is my final answer. The only difference between the first two examples and this third example, the only difference is that we now have an x involved. I still am going to do 2 parentheses, and I make sure that I have a line representing that we will have a value in the denominator. The symbol that goes in between these two values, in this case, is going to be an addition sign. So I've already used that addition sign. I always have to do this diagonal first when I multiply. 8 times 5 is 40. 3 times 3x is 9x. And when I multiply the bottoms, I end up with 15x. This is as far as I'm going to make you go right now. It's as far as you need to go. There's nothing more we can do to simplify this problem. 7 times 5 is 35. 4 times 3x is 12x. Multiplying the bottoms to get 15x. There is nothing more I can do with this problem to break it down. This is my final answer. All right, how do we go about doing this problem? So for this problem, the first thing we need to do is we need to look in the denominators and ask ourselves, can we factor? So we're not going to jump right into doing the butterfly method. I recognize that x squared minus 9 factors into x plus 3 and x minus 3, x plus 3 and x minus 3. So I'm going to rewrite this expression. 3 over x plus 3 and x minus 3 plus 5 over x plus 3. Now, in order to combine these, yes, I could use the butterfly method, but then afterwards it'd be a little more work in simplifying. I recognize that if I simply had an x minus 3 here, the denominators would be exactly the same. So I'm going to attach an x minus 3, and whatever we attach to the bottom, we must also attach to the top. That does not change the value of this original fraction. Now the bottoms both have an x plus 3, and they both have an x minus 3. When the denominators are exactly the same, I write down the denominator, and then on top I have a 3 on the left, an addition sign, and on the right I have 5 times x minus 3. So I'm going to quickly distribute this 5 and combine like terms, and I'm going to do that off to the side. So I'm going to come right up here and go, okay, I have a 3 plus 5x minus 15 when I distribute the 5, and when I combine like terms, I have 5x minus 12 all over x plus 3 and x minus 3. Please do not go ahead and FOIL or distribute the denominator. Leave it in this form. So for this problem, the first thing I'm going to do is I'm going to factor. So x squared minus 4 breaks into x plus 2 and x minus 2. If you just came in, you do need to have a partner. We're going to number you. Okay, so when I look at both the left and the right in this situation, I'm looking for that common denominator. What makes the denominators, the bottoms, look exactly the same? So these two parts are exactly the same, but this has an x plus 2. This is missing an x plus 2. So x plus 2 and x plus 2. All right, so what do I do next? Once the denominators are the same, I write them down. It doesn't matter if I put the group that's x plus 2 or x minus 2 first. Then I make two parentheses. In this case, I'm going to separate them by addition. In the first parenthesis is 7x. And in the second parenthesis, I could write this down, or I'm going to be lazy here. I'm going to do it at the same time. So 3 times x is 3x. 3 times 2 is positive 6. Now on top, when I combine like terms, 7x plus 3x is 10x plus 6. And this is as far as you'd have to go. You may see others that go a little further and recognize these are both even. So they factor out a 2 to get something that looks like this. But I would accept either the answer on the left or the answer on the What does this problem look like? Okay, let's look this over right now. So this is x plus 5 and x minus 5. This is already x plus 5. The right-hand side is missing the group x minus 5. So whatever I do to the bottom, I must also do to the top. Okay, so now what I'm going to do is, now that I have a common denominator, write x minus 5 and x plus 5. Doesn't matter if you put the plus 5 or the minus 5 first. And then I have two groups separated by an addition sign. I bring down the 9, and then I could write this down in this position, or I could distribute to get 2x minus 10. When I combine like terms, I end up with 2x. 9 minus 10 is minus 1 over x plus 5 and x minus 5. This would be my final answer. I'm going to let this class, I'm going to do it class by class. So depending on how hard you work, if you're present today, then you can replace Friday's test with tomorrow's quiz. I should say Friday's quiz with tomorrow's quiz. It all depends how hard you work and if you're present in class. I'm going to do it class by class. So here we go. Here's our next one. Now this definitely threw off a lot of people. We're going to go x minus 2 on top, x on the bottom, plus 4 over x plus 3. When you see this problem, I want you to recognize that x is not by itself in the denominator of the second fraction. It's with a 3. Okay, x is with the 3. It has a friend 3, and they are always together. This is just a single lonely x. They are different things. So a common mistake I'd see people make is go plus 3 because then the bottoms look the same. You can only multiply to get common denominators. So when I look at this part, I'm going, what can I do? I could do the butterfly method, or, so it's really up to you. Do you want to do the butterfly method, or do you want to go, this is missing a single x, so I attach a single x. The left-hand side is missing the x plus 3, And now I have the common denominators. The common denominator is x times x plus 3. I'm going to make a spot on the left and a spot on the right to do my work, and it's going to be separated by an addition sign. Now, on the right-hand side, it's pretty easy. In the numerator of the right-hand side, 4 times x is simply 4x. But I need to come off to the side, and I need to FOIL the numerator of the left fraction. So I'm multiplying the front to get x squared, multiplying the outsides, multiplying the insides, and doing the last. And when I combine like terms, I get x squared plus 1x minus 6. X squared plus 1x minus 6. This cannot be my final answer. I still need to combine like terms. And not only that, I'm going to write it in standard form. So when I look on top, I have x squared, 1x plus 4x is 5x minus 6. So I have x times x plus 3. Now, is it possible that I factor the numerator? I don't know. Is x squared plus 5x minus 6 factorable? Let's check. Our whole goal is to fully simplify our fractions. Do I know two things that multiply to give us negative 6 and combine to give us 5? Are there two numbers that are different signs that multiply to give you negative 6 and combine to give you 5? They're different signs with the larger number being positive, so that would end up with positive 6 and negative 1. I want to make sure I did this right. Multiply and combine. Now, it's really easy because the leading coefficient is a 1. So I can rewrite this right now. as x plus 6, x minus 1 over x times x plus 3. This is fully simplified. Not always will we be able to factor the numerator, but when we can, we want to put it in factored form. It allows us to see if we can simplify further. We go through doing this problem. Did you try it? Okay, this is a single lonely x. This is an x minus 2. There is a difference. So on the left-hand side, I'm missing an x minus 2. Whatever I attach to the bottom, I must attach to the top. On the right-hand side, I'm missing a lonely x. We have a common denominator of x times x minus 3. Whether you put the single x first or the quantity x minus 2 first, it doesn't matter. As long as they're both written on the bottom, they're being multiplied. Now, I have two quantities separated by an addition sign. The right-hand side is pretty. It's a 2x. I'm going to go through and I'm going to FOIL this. I'm going to get x squared plus 4x minus 2x minus 8. And when I combine like terms, I get x squared plus 2x minus 8. Now, my last step will be to combine x squared, 2x, and 2x is 4x minus 8 over this quantity. And I do want to ask myself, can I go ahead? Is it possible to go ahead and to factor this? Let's check. So what multiplies equal negative 8 and combines to give us positive 4? So 1 and 8, they have to be different signs. And the larger number is going to be positive. 1 and 8 doesn't give me 4. Does 2 and 4, because 2 and 4 multiplies to give you 8, does 2 and 4 combine to give you 4? It's not factorable. This is my final answer. Let's take a look at this problem. So our last two problems look similar to this. So what I'm going to start doing is I'm going to start by looking, can I factor? Notice that x does not go by itself. It's an x minus 7. They belong together. So I'm going to come off to the side and I'm going to try to factor this. 1 times negative 21 is negative 21. They multiply to give you a negative 4. Hold on 1 second. Okay, so they multiply it to give you a negative 21, combined to give us a negative 4. What two numbers would those be? Oh my goodness. They have to be different signs, so one's positive, one's negative. It would be a negative 7 and a positive 3. Negative 7, positive 3. They multiply and they combine. So it's really nice when the leading coefficient's 1. I can just write x minus 7 and x plus 3. Now I'm only focused on the denominators, just the denominators. They both contain an x minus 7, but the right-hand side is missing an x plus 3. So I'm going to start by writing down the denominators, x minus 7 and x plus 3. And then I'm going to make my two parentheses, and it's going to be separated by a subtraction sign because that's what the problem has. Now on the left-hand side, I have a 4x. And on the right-hand side, I'm going to go ahead, forget about this negative. It's already right there written as a subtraction. And I'm going to distribute x squared plus 3x. Now, a common mistake students are going to make is they're going to forget to distribute this negative sign. So I have 4x minus x squared minus 3x. What can I factor? Forget about the denominator. When I combine like terms, I end up with negative x squared plus 1x. This is the numerator. And that's not wrong, but what can I factor out? What do both of those groups called terms have? What do both of these groups contain? An x. So I'm going to factor out an x. I'm going to factor out an x, and I'd have negative 1x, because if I multiply x times negative 1x, I get negative 1x squared. Now, x times positive 1 gives us a positive x. I would allow you to leave it in this form, but I just want to show you how it's fully simplified here. On the bottom is x minus 7, another group of x plus 3. Check with your partner, please. Check with your partner and make sure you're both. Oh, you ready? I'm going to factor this. What multiplies equal negative 20 and combines to give us a positive 1? Okay, they're different signs, and the larger number is positive, so 5 and negative 4. When the leading coefficient is 1, it makes it easy. It's x plus 5 and x minus 4. So now I'm going to just examine the denominators. They both contain an x plus 5. What is the right-hand side missing? X minus 4, x minus 4. Okay, when the denominators are the same, I have like denominators of x plus 5 and x minus 4. I have two groups, and they're separated by a subtraction sign. I bring down the 2x. Now over here I get 3x minus 12. Now here's again where I think a lot of students are going to make a mistake. They're going to forget to distribute through. So I have 2x on top, subtract 3x plus 12 because it becomes a negative 3x and a positive 12. When I combine like terms, 2 minus 3 gives us a negative 1x plus 12 over x plus 5 and x minus 4. All right, so here we go. I'm going to go into x plus 7 and x minus 1. That's what this factors into. So I have 3 over x plus 7, x minus, I said x, let me go back. I should have said x plus 7, x minus 2. And I was able to get that because what multiplies to equal negative 14 and combines to give us a positive 5. That is going to be a positive 7 and a negative 2. That's how I came up with those values. But when I look on the right-hand side, it's missing the group x minus 2. Whatever you multiply on top, you must multiply on the bottom. So I have plus 2 times x minus 2 over x plus 7, x minus 2. Okay, I've got that common denominator. Wonderful. So I'm going to make two groups separated by addition sign over x plus 7, x minus 2. In the first group we have 3. In the second group we have 2x minus 4. And when I combine like terms, I end up with 2x minus 1 over x plus 7 and x minus 2.